Welcome, everyone. Good morning, good afternoon. Thank you for joining the webinar where we're talking about protecting APIs today. My name is Veena. I'm a product manager for Kong Gateway. My focus areas are API security, authentication, authorization, analytics, and API observability. So for today's agenda, we'll talk about recent breaches. We'll take a look at different categories of attacks. We'll talk about the security pillars that you should consider when you're thinking about a security strategy for your APIs. And we'll see how Kong can help secure APIs today. It's not a surprise that the internet, the traffic, the API traffic has surpassed all other types of traffic on the internet. Right? Cloudflare has confirmed that they're seeing over 80% to 85% of traffic, and they're all related to APIs. And this was predicted a while back, and it's just the popularity of APIs and their adoption and rapid growth. And it's also the flip side is that they're also growing as the number one attack surface, right? So the more APIs, more attack surface, and they're evolving and changing rapidly as well. So we have heard in the past about web security, application security. What the bad guys are trying is, the same techniques, and they're trying it against APIs. And for APIs, they also have some new and emerging threats, right, that are unique and challenging for APIs. So it's not for a lot of organizations, it's not the question of if a breach will happen. Of course, they want to avoid it at any cost. But it's more about when it might happen and how well prepared they are to continue doing business and having very little impact, right? So the top three concerns for any organization is protecting their assets and data, preserving customer trust, because once that is lost, it's hard to build that back up, and preventing any kind of financial loss, right? Be it in the form of revenue or loss in the form of having to pay huge and hefty fines in case of breaches. So here's a look at some of the recent breaches. There is a breach tracker for APIs that a company called Firetail maintains. I've taken just a few handful. And as you can see here, there's all sorts of companies there, right? Some well-known companies, some new applications, and even cybersecurity companies are on this list, right? Even they have APIs that were vulnerable. Bad guys were able to, hack and exploit that. A large number of these are authentication and authorization related. There are some breaches happening because of security misconfigurations. And in the case of those cybersecurity companies, injections were some of the attack vectors, right? So they were able to inject either a malicious code or malicious OS command and have it be executed on the device because the API was not checking for, it was not validating inputs, or it was, there was a way they could find to get it to execute and compromise the system. The US Patent Office, it had APIs where it was leaking PII data. So there was, in the API responses, you could see the PII data of all the patent filers. So there are, there are some classifications of attacks that we see we often see in these attacks, right? The first one, the account takeover, right? So here again, the authorization and authentication, as we saw on the previous slide, are the main reason that the bad guys are trying to take advantage of the fact that there is a weak access control mechanism, and you're able to break that or compromise, and you're able to impersonate users and get access and commit fraud. The second class of attacks, they're called the denial of service attacks. This is where there is lack of protection for APIs and the services. So the hackers are able to flood the system and cause the APIs to be unresponsive to legitimate use, with both DOS and DDoS type of attacks. So in the DOS, they're originating from a single source, whereas DDoS, they can amplify this impact by launching the attack from distributed systems. Again, here the goal, could be disruption, and it can also lead to financial loss, right? The services are not available for legitimate users. injections of malware that we saw in the previous slide for the cybersecurity companies. Again, there is lack of input validation or lack of any kind of sanitization of user-provided input, and the bad guys are able to inject malware or even compromise the system and leading to other types of attacks, right? So they can exfiltrate data and try to get into, they can have lateral movements. The account takeover, the denial of service, the injections, they're all coming from the web app world, right? So the same techniques are being tried against APIs. But APIs themselves also are vulnerable to other types of attacks, which are emerging, which are new, right? Here, there is no vulnerability as such. What's happening here in these case of abuse and bots is legitimate APIs are being used or misused and abused in certain ways, right? So there is a flaw in the assumption that these APIs won't be used in such ways, and there's no protection around that. It's a legitimate business flow, so they're attacking that business logic. For example, you might have heard of scalping, wherein when there are tickets for sporting events or music events, those are all, buying a ticket is a legitimate workflow, right? But with the bots, they're able to automate this against these workflows, and that can perform faster than humans. So you're able to purchase tickets, rendering it unavailable to other users. These types of attacks can lead to financial loss, and it's hard to spot it because it's a legitimate use of the API. Here's the OWASP top 10 list for APIs. OWASP came out with a list in 2019, and since then they have modified that in 2023. Some of the categories have, most of it has remained the same, but new categories have been introduced considering the new types of attacks that are emerging for APIs. For example, there is this unrestricted access to sensitive business flows, right? That kind of maps well into our abuse case, wherein the APIs are being abused when it was designed, where the workflow is legitimate, but they're just being used in different ways than what it was intended for. The top 3 of the top 5 are all authorization related. Again, authentication and authorization being the top most type of vulnerability for APIs. APIs are always dealing with objects. You're fetching data or writing data, and we're modeling, with the object-oriented approach, we're modeling real entities as real life, modeling it based on objects. So objects, they have identifiers, and without proper access control, there are different levels of broken object level authorization issues. One at the function level, where somebody is accessing functions that they are not supposed to, like an admin, a delete endpoint that should be available only to admin, but is available to others. And there's even more, in complex architectures, there could be different types of authorization needs where, it's hard to, you have to build this complex matrix, and unless you're looking for proper authorization checks, unintended users may be getting access. So Enon, who was supposed to be, there was a schedule change, but if you listen to his talks, he will go into deep about each of these different types of authorization issues and on the OWASP list. The misconfigurations are still continuing to exist, mainly caused by human errors. And there's the other category called the improper inventory management, which is also a huge problem for organizations because they have no visibility into the number of APIs they own, how many versions, etc. Right? So we'll talk about some of these in the next few slides. So now that we've seen the categories of attacks and different types of attacks, how can you protect APIs, right? What is a good API security strategy? Is there one solution that fits and takes care of everything? Because we see so many different solutions solving for different problems and different security needs, right? So the answer is not simple. You need to make changes. You need to have good both offense and defense strategies to completely, to offer better protection for APIs. you need to make some changes in the way you develop APIs and how you manage them, as well as have runtime protection to be able to react to when they're actually in production. So governance, again, if you look at organizations, most organizations, the teams that are actually developing the APIs and the services behind those APIs, they're different from people who are going to be responsible for operationalizing it, right? The people who provide the infrastructure for those, running those APIs, monitoring it, and making sure they're available and uptime and keeping up the uptime, et cetera, right? So they might be called platform ops, platform engineering, et cetera, in different companies. But these two teams, they need to work together, right? So they need to provide some kind of a framework or a guardrails based on which these different API teams can onboard their APIs in a consistent way, establish some guardrails so they're all developing to the API standards and deploying it, and the ops team is able to manage them once they're deployed. It's the other category that we saw, which was the improper API management. Again, not having the visibility on the number of APIs they own is a big problem, right? No one in the company is able to answer how many APIs they own or who to reach out to in case of incidents. So building up that inventory, bringing all those APIs under management, and actively managing the life cycle by retiring APIs that you don't use and knowing which versions are running in which environments is important. The third one is the InfoSec principles. This is not just for InfoSec. These are like golden rules that's applicable to everyone. These are like concepts like confidentiality, integrity, making sure that you're thinking about it as you design your APIs and your services, thinking about access control, who gets to access these APIs, what kind of access control mechanisms you have to put in place, and making sure that invariably APIs are going to fetch and manipulate the data. So you want to make sure the data is confidential and the integrity of the data is protected, right? So these are some of the golden rules that you have to think about even before you write a line of code. And you have to decide whether you want to be a spec first organization or you have to be a code first, right? So a lot of companies, again, the same problem wherein they have too many APIs, but they have no documentation and no one knows how to use it, right? So establishing a contract, adopting a spec first approach where the contract of the API is decided, and then you go and start coding. All these are good practices that you can adopt early on. Continuous testing, similar to your continuous integration and continuous deployment, before you even publish your APIs and your services, there's a whole bunch of testing that can happen, right? There are static analysis and dynamic analysis, security analysis that can happen on the code base, which runs and looks for vulnerabilities in either your code or in the third-party software that you may be using. So having those early on in the cycle, wherein even before you are ready to deploy your APIs, and incorporating some of these good practices will help in producing an output that that is gone through some level of security principles. Last but not the least, right? So when you are actually ready to publish your APIs, you want to be able to monitor the traffic, right? So you need to have proper instrumentation in the forms of logs, metrics on how you can monitor your APIs and troubleshoot and isolate issues should there be any incidents when it's actually in production. So you need to think about these offensive measures on incorporate some of these practices. For the defense, of course, when your APIs are out there, you need to be able to monitor the traffic and the behavior to understand, if it's being misused, or if it's being, if it's not keeping up the performance. So you need to have good observability. You need to invest in that, right? Nobody exposes the APIs directly, right? They are always going to have some level of layer of insulation in the form of API gateways, proxies, WAFs, firewalls, etc., right? So there is you're weeding out a lot of requests from even reaching your API layer. So some of these defensive mechanisms are needed, wherein you're exposing your APIs and offloading some of the checks to another layer. The bots, the new emerging threats that we see for APIs, there are protections and products that offer bot protection. They have this bot networks, it's probably signature based, wherein you can identify bot activity, and before it even reaches your APIs, you can drop such requests. And you need some kind of, it's very, the unrestricted access, that's a tough one to, it's hard to have something in the code, in the application or the API code. You need to build up, you need some kind of a machine learning process to understand the anomalies, to first have a baseline use case for normal behavior versus, what's an anomaly. So you need to build that up, right? So there has to be some kind of learning on the traffic patterns and building up that, so it can help with detecting anything that's out of the normal. So there are some security solutions that offer that as well. So you need both these offense and defensive measures when you're thinking about API security. So now the next question is, where do you enforce this security, right? Should you do that all in your API or the service layer, or should you have multiple checkpoints? So again, it's common these days. The gateway has become a common component in the stack, right? Gateways, proxies, load balancers, etc. And it can act as a layer of defense, right? So it can you can offload a lot of these security checks without having to handle all of them in your applications or your APIs, and offload some of this to the gateway. Again, this depends on your architecture, on the risk tolerance for your organizations. And you can have, they always say defense in depth, right? The more barriers, the harder it is for the bad guys to get through. So you want to have different layers where you enforce these checks. And some of the things that could be offloaded are things like TLS termination, traffic management, checking for access control, right? You can do some course level checks at the gateway and enforce rate limits so your services are protected from excessive usage. And some of the other misconfigurations that we often see, like excessive data exposure, right? So having something catch, you want to be in your APIs and your services, you want to log detailed messages so that can help you troubleshoot issues, but you may not want to send the same verbose logging and messaging to your consumers. So you can have the gateway layer do some transformations and send a generic message while it's logging it in the system for for further troubleshooting. So you need to think about, again, depending on the architecture, and in your service layer, you can enforce some business logic checks and fine-grained access control mechanisms, because your API, what your API, the business logic around that, right? So the gateway is agnostic. So you can have different checkpoints, and it's always better or recommended rather to have defense in depth, right? So having more barriers makes it harder. Let's see what how you can secure APIs with Kong today. There are a number of plugins that are available out of the box to address some of the authorization, authentication issues, misconfigurations, and I talked about both offense and defense. Kong helps with both of those, right? It is a lightweight API management software and gives you ability to have manage the lifecycle of APIs. So when it comes to, we'll talk about it in 4 different buckets. The authentication, the OWASP list is talking about login endpoints, right? So like endpoints that accept username, password, something like in a web browser, web application. And the vulnerabilities in those endpoints are that, because it's by nature, it's open to everyone. A lot of people try to do brute force, or they might do some kind of a credential stuffing attack because they're able to buy usernames and passwords from all these different breaches, and they keep trying to use and break using the same name, right? First of all, there is no protection. If there is any lack of protection on the number of attempts, they'll keep trying until they succeed. So it's important to rate limit such authentication endpoints wherein you are looking at 5 attempts or 6 attempts, and then you're locking the account. So you see this in most of the web applications today. It's not just the login endpoints, anything related. There have been incidents where forgot password workflow was misused or something like that. So it's important to apply the same protection to those other endpoints as well. Doing multi-factor authentication. All this is easy on the web app side, but what about the APIs, right? How do you protect APIs? It is a well-known and well-documented issue that your APIs should be handling only authenticated requests, right? So there are many ways that Kong offers you to protect endpoints. One is the level 0, which is the basic auth or API key. It's very common still, even though it's level 0, according to security experts, it is still in use. A lot of APIs are protected by API keys. At least there is some protection, right? Then there is certificate-based authentication. You can have your API clients use certificates to authenticate themselves, and you grant access based on that. Or you can use JOT tokens as API keys. They're short-lived and they're not as static as API key. So you can use JOT tokens as API keys for authentication. If you want to do delegated authentication, we have the OpenID Connect, wherein you can have your users, if there is a user behind that and you want a user to log in, they can log in at a third party like an IDP, and a token is granted based on the person logging in, and the token gives access to the APIs. Now, how do we do multi-factor authentication for APIs, right? So it's not impossible. There are other techniques to ensure that even if you may be using token-based architecture, there are ways the tokens can get stolen or leaked. How do you protect in such cases? There is some concept called a proof of possession, right? It's not exactly multi-factor, but this is an approach you can take wherein you're not only validating that the request is coming in with a valid token, but you're also validating that the token was actually issued to that presenter, right? So there is some two-level protection there, and you're not just accepting any token, right? So if you wanted to go further, level 3 or level 4 in supporting authentication, you can do that as well. For authorization issues, again, as I mentioned, you can do coarse level at the gateway. You can do fine level. We have a variety of plugins that support that. Right now, you have to have some checks at the API layer as well, because you cannot really protect a bad API. But you can enforce, multiple places where you check for authorization. So using the OAuth flow, you can use, again, token-based architecture. You can look at scopes, claims, and look for permissions, whether that user or the client is having enough permission to access this endpoint. You can build access control lists. And if you're, if you're not having delegated authentication and authorization, you can use what is inbuilt in Kong with consumers and consumer groups, and use RBAC model to enforce some layer of check, based on which users can use which endpoints. You can apply that on the route level as well, right? So you can expose the routes and limit the number of methods that the users can invoke on that method. And so there are multiple options when it comes to authorization. If you're, if you wanted to do fine level checks, we offer something called Open Policy Agent. Open Policy Agent uses like a P*P architecture. There is a policy enforcement point, and there's a policy decision point. So the gateway obviously would be the policy enforcement point, and all the policy decisions and policy creations would happen at the policy PDP, the policy definition point, wherein you can create this matrix of complex policies, which user can access which resource and what permissions, and can build this complex matrix and just have the gateway enforce based on the result of that evaluation of that policy. When it comes to misconfiguration, again, there are few plugins that we support out of the box. Mostly these are caused by humans, right? You clone an environment, maybe you forgot to completely set it up and you left some ports open. The goal or the best practice here is to think about least privilege, right? So you have to grant access rather than limit access, right? So if you think about least privilege, you can enforce some of these restrictions on the APIs that you're exposing, right? Things like CORS, only allowing certain origins to access the APIs, or building an IP restriction or an IP rules based on the IPs, allowed IPs and denied IPs. You can also enforce TLS. So your APIs may not be HTTPS, but you can enforce your TLS for your. You can expose it as an HTTPS endpoint. Can do error and response transformations, as I mentioned, so you're not leaking excessive data. You can catch those. You can have the gateway intercept those and return a generic error to your consumers and log it for your own purposes. You can set rate limits on the APIs. You can set limits on a variety of attributes like consumers, consumer groups, routes, services, IP address, etc. Right? So you can also create a tiered approach to rate limiting, wherein you apply one or more rate limiting plugins and achieve that tiered approach. You can drop requests at the gateway that are over a certain size, so it's not even reaching your backend. Right? A lot of protection that you can enforce at the gateway, so your APIs are secure, are not even processing requests that don't meet some of these standards, right? You can have content inspection. Now, it's good to do the checks for input validation, validate the payload or inputs in the APIs themselves, in the API implementation. But at the gateway layer, you can enforce schema checks, which will check for whether whether the payload is adhering to a schema. If not, they'll reject right at the gateway. Like you can do other types of inspection, like inspecting the JSON depth by setting some limits. Like you may be not having any protection on your APIs, but you can enforce. You can avoid the APIs going into a spiral and handling bad input and have them be dropped at the gateway itself by doing content inspection and regex matching. So the other thing that I mentioned about Kong being a lightweight API management, again, going back to the OWASP list, which included improper inventory management, this kind of addresses that, wherein you are able to, it gives you a platform for you to bring all your APIs under one control and offer governance and visibility as you build the catalog. You can consistently deploy APIs, your different teams, and manage the lifecycle of APIs. You can control the sprawl, right? You can control how many versions are out there, retire the versions that are not being used, because now you're collecting metrics, how many API, which versions are not being used at all, and retire those, and reuse assets, because now you have the visibility of, different teams have the visibility of what is available, what APIs are available. Another component of inventory management, or another component of API management, is the developer portal. You can have a workflow which keeps your API documentation. Again, goes back to that offensive measure that you have to decide whether you want to do spec first approach, and assuming that you're keeping your API specs in line with the implementation. As you update and make changes to your APIs, you can publish the API documentation to the portal, which will help with two things, right? First, it's keeping the docs current, and you're helping with consumers, onboarding consumers to those APIs and adoption of those APIs, right? So the developer portal can help you with that aspect. Of course, the API management platform comes with observability as well, right? So we have tons of plugins where you can export logs, metrics in OTel formats if you have to. And it also offers analytics and observability on the API traffic. So the main thing that I want to highlight is, again, it's not a one solution fits all. You kind of need to make changes. You have to adopt both some of the offensive techniques and defensive techniques as you think about API strategy, right? So you catalog all your APIs. You'll hear this repeatedly from from everyone in the industry, right? So it's important to catalog and govern each and every API. Enforce policies or multiple enforcement points where you can enforce these security policies that you define for your APIs, and monitor all the traffic, right? So you have good observability on the traffic so you can react. So that brings me to the end of my presentation. Those are the top two things that I want you to take away, that you need to have some offensive measures as well as defensive measures. If you have any questions, please ask them in the Q&A. I'll be monitoring those. Thank you.